All right, it's 8:05, so I'm going to get going. Good morning, everybody. Welcome to day 23 of the online Rankin Technical College C# programming class. Somebody need to be. So today we're going to begin Murach chapter 8. I have gathered everybody's tests and homework, and I plan on going home and grading those, as many as I can possibly grade this afternoon. All right, so we're going to start on Murach chapter 8 today. We're going to do it a little bit differently, and you'll see in just a minute what I mean. And we'll continue with chapter 8 pretty much for the rest of the week, if not the rest of the week. All right. Now, remember, your completed chapters 6 and 7 hands-on test was due now last Wednesday. So if for some reason you haven't turned it in, please do as soon as possible. All right. Your completed homework for chapter 6 and 7 was due yesterday. All right. Your completed homework for chapter 8, which we're getting on now, and I'm going to give you the homework tomorrow morning. All right. And written test, and that shouldn't be tests, it should be test, because there's only one. That'll be due. Since there's no class next week on Monday, I decided to make that due Monday instead of Sunday. All right. Okay. So with all that said, what I'm going to do, we're going to go into chapter 8. We're going to get through as much of it, hopefully all of it today. But I'm going to start this by doing something different. And that is, I'm going to start up Visual Studio. And I'm going to call this just, I'm going to make a folder here that I'm just going to call test demo. No, let's call it array demo. All right. And it's not even going to use arrays at first, but it will in just a bit. So I'm going to create a new project. I could do this as either a console or as a Forms app, but you know it's much easier to see Forms apps. So we're just going to call this array demo, and we'll keep everything as array demo. That's totally fine. There's only going to be one project in here. All right. So there we go. Okay. So we're going to imagine for just a second as we come in here, and I just do a couple of the things that we typically do as we get started. All right. We are going to imagine in here that we have a classroom, and that classroom has in it, all right, that classroom has in it, we're going to say, I don't know, 6 students. All right. And we're going to put those in just a moment. All right. So what do I mean? I want to show you exactly what I mean. So I'm going to create, as we typically do, our 3 buttons. Oops, only need 3. All right, so there's our 3 buttons. And we're going to have, it's going to be, like I said, a very, very simplistic type of interface. We're going to have 2 labels. And with those labels, we're also going to have 2 text boxes. Like I said, this is just going to be a fairly simplistic example. And when you first look at it, you might say, we're not learning anything here. Just give me a second and hopefully you won't feel that way. All right. We're going to keep this pretty simplistic, as I said. This is going to be the name, and we're just going to put in a first name of a student. All right. So this will be TXT name. All right. And this is going to be, we're going to call it grade. This is nothing we haven't already done in here, but there, believe it or not, there is a reason I'm doing this and a reason I'm doing it the way I'm doing it. So if you bear with me for a second, hopefully you'll agree. All right, I'm going to call this one just add instead of calculate like we usually do. All right, this one is going to be our typical clear. I didn't even change the name of the form. I should have, but it's okay. All right. Did I rename everything else? So everything except the form has been renamed. All right, let's lock the interface into place. Let's quickly set a tab order. We are going to allow the student to put in both a name and a grade. So that's 0, 1, 2, 3, 4, 5, 6. All right. Now, if we run this, it'll look just fine. Of course, it doesn't work. We haven't put any code in there for it yet, but everything is fine. All right, and I'm just going to change the name of the form to grades. All right, now let's just get a couple things out of the way first. And that is, let's finish, get our clear and our exit out of the way so we can actually get into this and you can see what it is I'm trying to show you here. Now, again, we're going to imagine for just a second that what we have is we have about, like I said, about 6 students. Okay. Now, think about this, if you would. There's nothing in add yet. We're going to put that in a minute. But let's say that I come in here and I've made 6 mythical students. There's Kate, Carl, and Ken's, Bill, Barb, and Bart. And we're going to give each one of them, we're going to put in their name and we're going to put in their grade. All right. Okay. And there's lots of ways, and I know you know this, there's lots of ways that we can do this. All right. So let's go into the add, and I'm going to come in here and I'm going to put in add student. We're going to call another routine. Now, just so you know, as we start with this, I'm not going to put in a min grade and a max grade. I'm not going to put in generic validation routines. I'm not going to put in try catch. I'm not going to put any of that in because I'm trying to show you something else here. All right. So again, here's our add student. Okay. And no, we don't need that. That can be a void. Okay. So right now I have no errors. I can run it. I can clear, but it's not saving anything. All right. Well, I want to be able to save each student's name and each student's grade. There's a problem though. If I do this, so if I come in here and I say string output str equals nothing, all right, and then I'll say output str plus equal name plus txt name dot text, okay, and then I'll say again output str plus equal, and now I'm going to say grade all right, plus txt grade dot text. Okay, and that'll work. Okay, as far as I know, it's going to work just fine. Okay, I'm not going to use this even though I've got it. There's not going to be no show error message in here. There's a problem though with this right now. And what do I mean? I'm going to run this. All right, so I'm going to come in here and I'm going to put in Kate. And Kate got 91. And I click that. Oh, I'm sorry, I never said it that I wanted to print this. So let's do it. We will do this message box. All right, I'll just call it show message instead of show error message. So here, after we've done that, we've entered all the person's info. We'll call, what was it? Show message, and we'll put in there the output string. All right, and we'll put in here student grades. All right, so we run this. I'm going to come in here, and again, Kate, 91, and hit add. And what do I get? Name, Kate, grade 91. Well, I should have put an enter in there, but that's okay. You understand, at least, I hope you do. That's working. All right, so we can come back in here. Where is that output string? Here. So before this, we will put in a \n. All right, let's do it one more time then. All right, we'll put in Carl this time. Carl didn't do as well. He got a 77. All right, so Carl 77, but notice, okay, if I run it again, if I click OK, and now I come in here and let's put in Kate again, 91. All right, well, where's Carl? Carl's gone. Carl did not persist. Can we make Carl persist? We're going to try right now. All right, I'm going to take this where it says string output str, and I'm going to put it at the top of the program. So I'll put in here, declare and initialize class variable. And there it is. Okay. So we've got that in there now, but it's still not going to work. So again, Carl, 77. Okay, that's in there. Fine. All right, we'll clear Kate, 91. We have the same problem we did before. Oh, we don't. There's Carl and there's Kate. All right, so it does look like it's keeping them. All right, by making this global. I was going to make this static because I thought I'd have to, but for some reason, it appears as though I don't. So let's put a \n here and let's run it again. All right, so Carl, 77. There it is. All right, we clear, we'll do Kate, 91, and we'll add, and it's working. Okay, and it's not bad. All right, it's not a terrible program. Okay, now I'm going to take this same program. This is going to lead into what I want to get into in just a second. All right, I'm going to grab this same program that we just did, and I'm going to create it again, but I'm going to create it as a console program. There's a reason for my doing this, so please just bear with me. So I'll call this array demo console. All right. Okay, so we're going to imagine now we've got all 6 of our students. Okay, we have 6 different students. Okay, so we're going to kind of do what we just did a minute ago. All right, and that is I'm going to come in here and I'm going to create, okay, I'm going to have string student1, and we'll put in here string student2, string student3. It said we're going to have 6 of these. String student4, string student5, and string student6. All right. Then we're going to have int grade 1, int grade 2, int grade 3, int grade 4, int grade 5, and int grade 6. Hopefully you can already see where this is going. All right. It's kind of a cluster, for lack of better words. I'm throwing everything we have here, I'm throwing it inside of main. All right. So I'm going to come in here and I'm going to say write, enter student 1 name. Okay. And then I'll say, oops, I forgot the semicolon. And then I'm going to say student 1 equal, I don't need the console in there. So student 1 equal read line. Not a problem. All right. And now I'm going to come in here and say, enter student 1 grade. All right. And again, I'm not worrying about validating anything in here right now. So I'm going to say grade 1 equal convert dot to int 32 read line. I got to fix that O in there, as you can see. Okay. Now, let me hit enter here once. Now I'm going to come in here. Now we have all 6. All right. So I've got to make some changes, of course. 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. I either made too many or I overwrote something. 1, 2, 3, 4, 5, 6. All right, I don't know why I put that many in there, but I did. All right. So this should work. Okay. And I can put everything in there afterwards. So in other words, I can still have my output string here. So I can say string output str, and we'll initialize that to nothing. Okay. All right. So we've got that. And as I'm reading all this stuff in, I can say output str plus equal, and we'll put in here a \n name plus student 1 dot, not just student 1, that'll work, plus grade plus grade 1 dot toString. Okay, let's see what it doesn't like here. Output str, output str. I spelled it wrong, so that's probably why. All right, so plus grade 1, there it is, dot toString. Oh, it's telling me that so all of these are going to have to be assigned equals 0. So let's just put these in here. All right. So now I can go and add all these. 3, 4, 5, 6, and we don't need these two. So we can say right line output str. And I've got to make some changes. You know that. So what do we have here? All right, student 1, this will have to be student 2. So all of these will probably have to be initialized. That's not a problem. We'll fix it in a second. That's student 3. That is student 4. That is student 5. 4, 5. Good gravy. All right, let's initialize all of these. All right. Okay, there's no errors. Good. Now, you might say, yeah, this is taking you a hell of a long time. That's what I'm trying to show you, believe it or not. All right, so let's see. 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3, 4, 4, 4, 4, 5, 5, 5, 5, 6, 6, 6, 6. Good. All right, so let's run this. I've got to make this the active project. Set a startup. And again, let's run it. All right. So Barb got an 88. Okay. Ben got a 91. Mary got a 100. It doesn't like something. Wish I knew what, but try it again. Let's do this. Let's grab every one of these output statements and let's put them all at the end. And what I'm doing right now, believe it or not, I'm not wasting your time. You probably think I am, but I'm showing you what a pain in the butt it is to do things like this. And we're going to fix this in just a couple minutes. All right. And after we get done with everything, we're going to say, put a read line in there so it doesn't fly off the screen. All right. So 6, 6. Okay, I don't see any errors. I don't know why some are gray and some aren't, but they are. So let's see if this fixed it. All right. Barb, 91. Betty, 83. Bill, 66. All right. So what do we have here? Printing them all out, but for some reason, five, 5, 6, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Okay, now all of my odd ones are in gray, which I don't understand, and all of the even ones are not. So 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Let's run it one more time. All right, student 1 name, Bob, 66. Okay, it's skipping, so it's enter student 1 name, enter student 2 grade. All right, so it's going here and it's doing this, enter student 1 name. Ah, it's because I did it wrong. Okay, we'll fix it. Okay, so enter student 1 name. That was the problem. Enter student 2 name and student 2 grade. Enter student 3 name and student 3 grade. It's all on me. It was all my fault. So All right. 4, 5, and 6. All right. So 1, 1, 2, 2, 3, 3, 4. Well, that should have been. 4, 5, 5, and should be 6 and 6. All right. I don't know if I did it right or not, but let's look. All right. Bob, 88. Betty, 100. Barb, 73. Kate, 91. Carl, 34. Hens. All right. Input string was not in the correct format. Okay. So this is wrong. So we said 5, 5. This one shouldn't be here. All right. Finally, after all this, and hopefully what you're seeing right now is just what a pain in the butt it is doing this. All right. So Ken, 100. Carl, 56. Kate, 99. Tim, 88. Tom, 77. Tina, 100. Okay, now I've got everything in here. I didn't do a good job, but some of it's screwed up, and you're already seeing what a pain in the butt this is. All right, the names, look at this. I screwed up. And the grades, I screwed up. So I screwed up number 2 and number 4. Now we can fix it, all right? But what a pain in the butt this is. So 1, 1, 2, and that should be a 2. All right, so this should be a 3. Wait a minute. 1, 1, 2, 2. Look at that. 3, 3, 3, 3, 4, 4, 4, 4, 5, 5, 5, 5, 6, 6, 6, 6. Now, after all that, after you probably think wasting your time for half an hour or so, we should now have it. Barb, 100. Betty, 96. Ben, 77. Kate, 100. Kelly, 98. Tim, 45. And, well, there's still one screwed up, but you can see it's just about there. All right. Okay. So why did I waste your time showing you all this? I'm going to show you this right now. All right. And when you first come in here and you take a look at the syntax, it's going to look a little weird. All right. But we're going to go over all of it because that's what chapter 8 is all about. So I'll fix these later. But for now, I'm going to take everything I put in here, everything, the whole shebang, as they say, other than the read line, and I'm going to comment it out. All right. Now what I'm going to do is I'm going to create 2 arrays. One array will hold my 6 student names. One array will hold my 6 student grades. Now, if you're confused, and some of you were in the AWD1000 class last semester, and we went over arrays with JavaScript. Some of you were not in that class, so you may or may not have ever heard of the word before. But imagine this, all right? My daughter lives in St. Peter, Missouri, and in the neighborhood she lives in, at the end of the block, they literally have a big mailbox that's there that's got about 30 slots in it that the mail person can open it and put in the mail for each person. That's kind of what an array is. It's basically one piece of data, all right? And when I say one piece of data, it's known as a data structure that can hold many different things. All right. Now, we're going to suppose right now we don't know the students' names. We're going to suppose right now we don't know the student grades. All right. So I'm going to come in here and say string, and then you say bracket, bracket, and this will be names equals new string of size 6, because we said we're going to have 6 names in there. Then I'm going to say int bracket, bracket, grades, and that's going to equal a new int of size 6. Let's make even these out so you can see what's going on here. All right. Now, you might say, fine, just what did that buy us? Let's take a look. Let's come in and still have like we did before. Let's have our string output str, and we'll set that equal to nothing. Now, just so you know, automatically when you create these arrays in C#, not every language is like this, but C# is like this. All right. These are all automatically set to the empty string, automatically. And it didn't matter if you put a 6 in there or a 6,000, every one. These are automatically set to 0 without you having to do anything. All right. So what I'm going to do now is this. I'm going to write a for loop, and I'm going to see that if I can replace all of this stuff that you see in here. So when you think about it, we started what? So at line 17 and all the way down to line 74. All right. So that is somewhere around 50, 55 lines, something like that. I'm going to see if I can replace that with 3 or 4 lines. All right. So I'm going to say here for. You know that when I write these, I call my loop control variable LCV to stand for loop control variable. All right. And that equals 0. LCV is less than, I can pick names or grades because they're both 6 in size. So length plus LCV. All right. Now I'm going to come in here, and I guess it won't be 4 lines, but it'll be 10 or less. So now I'm going to come in here and I'm going to say, write enter grade for student. Now, if I do it like this, when you start working with grades, the first one will be grade 0. So the first student will be student 0. I don't want that. All right. So what I'm going to put in here is LCV plus 1. Okay. So if I did this right, what this is going to say then is enter grade for student 1, then enter grade for student 2, then enter grade for student 3, etc. And it'll keep doing that. All right. So I've got all that in there. I'm getting an error because I need to end my parenthesis. All right. So now we can come in and say read line. All right. But I want to be able to set up my name. So names LCV equal read line. Just like that. All right. Now, what is it complaining about? Let's look. So we've got here read line. The name read line does not exist in this context. Well, that's interesting. All right. We'll fix it in just a second. Names LCV equal shouldn't be console.readline. All right, it wanted the console, but even though we put that in there, we shouldn't have had to, but that's okay. All right, now I'm going to do the same thing All right, down here, I'm leaving some space because I'm going to come back. So this is enter name, enter name for student. And now this will be enter grade for student. So this will be grades. All right. Okay, so grades. Now I'm getting an error here because it's reading it in as a string. So I'm going to change this to convert.to int 32. And just like I did before, because I type way too fast for the computer. So put that in there as an O. All right. Now I've got all of that. I've got my name for each student and my grade for each student, but I want to be able to add that in here. So I'm just going to grab one of these lines, paste that in, and now I'm going to say output str. Don't worry, we'll fix it right now. Okay, name. So this will be names, LCV, and this will be grades, LCV. All right, all my errors are gone. So if I counted right, when we did this, we started on line, now it's line 26. So 26 all the way through 82. So 82 minus 26 is 56 lines, plus 1 is like 57 lines that I've replaced with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines. And out of those 10 lines, 2 are blank, and 2 are my beginning and ending curly brace. So if I got rid of all the blanks and I put my curly here and here, it would basically be replacing it with about 8 lines, 7 lines, whatever. Let's see if it works. Right? That's the big thing. Now, when I'm all done here, I still want to put in my right line of output str. All right, I still need that because otherwise it's not going to show anything. But let's see if it worked. All right. Whoa, 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 whoa. All right, so enter name for student 1, Betty. Enter grade for student 1, 100. Enter name for student 2, Bob. Enter grade for student 2, 78. Enter name for student 3, Mary. Enter grade for student 3, 89. Enter name for student 4, Bill. Enter grade for student 4, 87. Enter name for student 5, John. Enter grade for student 5, 91. Enter name for student 6, Lisa. Enter grade, 99. And you notice it prints, everything is fine. Should have put a colon there, but who the heck cares? The point is this. All right. You saw what a pain in the butt this was. And I'd like to tell you, I did that on purpose just to prove a point, but I didn't. I just screwed it up. I can see right here, this should be grade 1. So that was one of my mistakes, grade 2. All right, grade 3, grade 4, but that should be, etc. So one of these is wrong. All right, so student grade 4, and that then enter the name for grade 4. So this is why I screwed the other one up, not on purpose. All right, but either one of these ways would work. All right, but I think at least, hopefully, you'd agree that this way is a heck of a lot easier. And if you don't agree, just imagine this. Imagine that instead of having 6 students in the class, we have 60 students in the class. Would you really want to make student 1, student 2, student 3, 60 of those, and then make 60 of these? All right, if this changes to 60, all we have to do is add a 0 there and add a 0 there. That's the only changes we have to make. Not only that, if we want to, we can, because you'll see this a lot. All right, because we've been working with constants, so I can declare, not del care, declare and initialize program constants. A lot of times you'll see const int size equal 6. And then these will both be size. Okay? You don't have to do it like that, but you often see it like that. All right, couple things here. First of all, these arrays that you see on your screen right now, they're known as parallel arrays. They both have the same number of what are called array elements. They each have 6 of them, and they run in parallel with one another. So whenever we enter a name, we enter a grade. And whenever we save the information for a name, we save the information for the grade. All right. Now, do they have to be the same size? No. But in this case, for what we're doing, it makes sense. All right. Now, you might say, well, what if I had 5 different grades? Well, there's different ways you could handle that. You could make 5 of these, or you could make literally what's known as a 5-dimension array. And if you say, I don't know what that means, we're going to go over it in class. All right. But I wanted to show you that not because I wanted to confuse anybody or screw you up, but I knew that me doing this, I knew I'd make mistakes just because that's me. All right. Not only that, you remember I said I forgot to put the colon after grade? Well, guess what? There's only one place I have to put that, and that's right there. And now it's going to be put in there whether I have 6 or 60. It doesn't matter. All right. So again, this is how you declare an array. You give it a type. So you can have an array of strings. You can have an array of ints. You can have an array of decimals or doubles. You can have an array of Booleans. And there's other kinds that you're going to see when we get a little further on in the book that you can have. So any of the data types that we've used thus far, you can create an array of that data type. Now, the difference is everything we've been doing so far, when we were working and doing stuff like this, all right, these are all known as scalar variables. Every one of those. What does that mean? That means they can only hold one value at a time. You can change the value. If I put Mary in here and I made a mistake, that should be Betty or something like that. I can change that. Oh, I gave them a 57. That should have been a 75. I inverted the numbers. I can change that. But in all of these, with scalar variables, they can only hold one value at a time. Now, these are known as data structures. They can hold multiple values at one time. So basically, when you work with an array like this, when you work with an array, it is a data structure, all right, that allows you to hold a certain number of variables. Just in the same way as I mentioned before, you could have a different number of mail slots. So one neighborhood, if they did it like that, may have 40, one may have 30, etc. Now, what we're going to talk about for the majority of Chapter 8 are arrays. When we get to the end of the chapter, we will talk about collections. And in particular, we're going to talk about what are called lists, L-I-S-T-S, lists. What's the difference between an array and a list? Now, those of you who were in the JavaScript class last semester, this is different from JavaScript. All right. And I'm just going to put it up here, and I'll put it up here just as a comment, just so you see it. All right. Okay. And that is, oops. Arrays are fixed in size. So once I create an array like this of size 6, I cannot make it bigger. That doesn't mean I have to fill up all 6 locations. All right. But if I don't, if I only fill up the first 5, then the last one, the name will be the empty string and the grade will be a 0. I can do that. But arrays are fixed in size. And a couple more things about arrays. Arrays are known as being early binded. What the heck does that mean? That means that when you compile the program, you're converting it from these English-like words that we use to the zeros and ones that the computer understands. All right. That means arrays are fixed in size because they're early binded. And what that means is the compiler needs to know exactly how much space to put aside for each array. All right. That's why they're fixed in size. But what you'll see later when we get into them is, as an example, lists are not fixed in size, and lists are known as being late binded, which means that they're set at runtime. And if you don't understand the difference, I cannot change the size of this or this when the program's running. If I had made these lists, and you'll see them later on in the chapter, I can make these bigger or smaller. They're actually kind of cool because if you don't give a list a size, if you don't give your list a size, it automatically gets a size of 16, which means it can hold 16 things. So if we made these lists and we didn't give them a size, it would be 16 names and 16 grades. As soon as you fill up all 16, it automatically doubles. So it becomes 32. Once you fill up the next 16, so you got 32 names and grades, it doubles again to 64, then to 128, etc. So if I did set it up and I set up a list with size 6, after I put in the 6th name and grade, it would double to 12. All right, so you're going to see that. Okay, so lists are much more versatile. They're much more versatile than arrays are. All right. That said, when we go back in and we look in here, so if I go out to learn.microsoft.com and I come in here and I put in C# arrays, what you're going to notice when we start to go through them, all right, and I don't know if it's here in the language spec or not, what I'm looking for, but arrays have a boatload of methods that are associated with them. And of course, it's not showing me here, but let's look for C# array methods. Okay. Hopefully that'll find something for us. No, it doesn't seem to like it there. So let's bring it back to here. All right. So array.sort is a method we're going to look at. It's an example. This is just one of the methods because you can sort in a bunch of different ways. But if I come through here and say listing of C# array methods, I don't know how many there are. Here, that's what I was looking for, was the array class. But if we look in here, those are properties. So these are the methods. 1, 2, 3, 4, 5, 6. I don't know how many there are. But I think you'd agree there's a lot of them. I'm not going to say it's probably 100. And there's a bunch of things that you can do with them. Now, a lot of them, notice sort array. So a lot of them are not duplicates, but they're different ways that you can use this. But there still are probably a good 30 or 40 different array methods. All right. Now, if I come through here and say listing of C# list methods. All right, so there's the list class. And if I go down to do the same thing and go to methods, say, well, there's just as many. No, there's not. All right, there's probably at best half. So sometimes when you know the amount of things you are working with, it pays to use an array. But if you've got something that's going to vary over time, where you're constantly going to be adding things and removing things, then a list might be the better option. All right, so we're going to talk about both of those. So as you can see, lists are a type of collection. And again, don't worry about all this terminology. We're going to look at all of it in here. All right, as it says, as you develop C# apps, you'll find many uses for these. I'm not going to read that. You can read it. All right. In this chapter, you'll learn the basic concepts and techniques with working with both arrays and collections. The chapter itself, 230 to 270, is 40 pages. The first 25 pages, approximately, are on arrays. The last 15 pages, approximately, are on collections. We're not only going to talk about lists, but we'll say a few words about sorted lists, queues, stacks, and an actual array list. But the majority of this chapter that we're going to be working on right now, all right, is arrays. So we'll first talk about one-dimensional arrays. And guess what? We already have. That's what I was showing you. I showed you two different one-dimensional arrays. One to hold 6 names and one to hold 6 grades. All right. Then we'll talk about rectangular arrays. All right. What the heck is a rectangular array? Well, it's kind of, if I come in here and type in Excel, and I bring up an empty Excel spreadsheet like this, okay? This is kind of a two-dimensional array. Now, if you look here, it tells you right here that I'm in column A, right there, and I'm in row 1, A1, column, row. The difference is when you work with arrays, I'm just going to show it to you like this. So imagine we had this. What do we have? We have 1, 2, 3, 4, 5, 6 rows and 1, 2, 3, 4 columns. So this right here, this is row 0, column 0. This is, all right, row 1, column 0. And as you can imagine, if we took these down, all right, nope, didn't work the way I wanted it to, so that's fine. So this would be row 3, column 0, row 4, column 0, row 5, column 0, and row 6. I'll leave it at there. I think we had that many rows in there. So this would be row 0, column 1, row, etc. And we could just keep going down. All right. The reason I'm telling you this is when I go into after the break and we start talking a little bit about arrays of multiple dimensions, most people tend to get confused. So I like to use an analogy like working with a spreadsheet, because if you've ever worked with a spreadsheet, in essence, you've already worked with a two-dimensional array. The biggest difference is in spreadsheets, it's in column row order. So you say the name of the column first, then the name of the row. All right. In programming languages, you say the name of the row first and the name of the column second. So rather than it being in column row order, it's in row column order. All right. That's the biggest difference between the two. All right. So we're going to talk about that. All right. Under this more skills for working with arrays, we'll take a look at some of those built-in methods, all right, that I just showed you that were out there. Then we'll go into collections. the most useful collection, in my opinion, for whatever that is or is not worth, is working with a list. That's the one we're going to spend most of our time on. All right. And we're going to take our time with this, just so you know. All right. It is 9 o'clock. It must be almost 9:01. Let's take 10 minutes, come back at 9:10, and we're just going to pick it up by going through what's in the book. And I'm going to fix this program during the break. There we go. All right, it's 9:10, so let's continue on. And we'll start with our array stuff right now then. All right. As I mentioned, what we've been working with so far has been a one-dimensional array, sometimes called a 1D array. All right. There's different ways that you can create these. Now, unfortunately as well, there's different terminology that you'll see used, which means the same thing. So let's turn to this page here and look. So you can set it up like this, all right, like I did, and put it in as two different lines. In other words, just like with a variable, you can declare it on one line and assign it on another line, all right, or you can do it in one statement. Again, pretty much the same way that we've done this with quote regular variables. And I'm not going to say that anymore. It's the way we did it with scalar variables, all right? So they show a couple or an example of that, and then an example of doing it as one. Now, there's another way that you can do this. I want to show that to you right now. I'm going to go back to the same program that we were just looking at in here. What if I'm playing a game right now of what if? Okay. And what if we already know the names of our 6 students? And what if we already know their grades? All right. So this one works now. I've fixed all the mistakes that were in here, but I'm going to comment this whole one in here out. All right, I'm going to comment everything that's in here out. And I'm doing this so you can see a lot of different, ways of doing not exactly the same thing, but pretty much the same thing. So I'm going to assume we have 2 arrays again, but we know our 6 student names and we know our 6 student grades. So I'm going to say string, bracket, bracket, names equal, and I don't have to say new string. Inside of curly braces, I can put all 6 of the students. So Kelly, Katie, Michael, Mark, Mary, and let's put in Mindy. All right. So now I've got 6 students. And when you do this, you can put them each all on one line like this. You can put each one on its own line. You can, it's totally open the way you do this. So now I'm going to say string, not string, I'm sorry, int, bracket, bracket, grades equal, and I'm going to do the same thing. We're going to say Kelly got 100, Katie got a 97. All right. Michael got an 80. Mark got a 70. Mary got a 67. And Mindy got an 81. All right. So now we've got that. Whoops. And you'll notice when you look in here, I'm not getting any errors. Typically what happens for whatever reason is it puts a blank space at the beginning and at the end of each one. I'm not sure why it does that, but it does. All right, now I'm going to grab that for loop that we had. Okay, and just grab all of this, but I'm going to get rid of most of it in just a second. All right. Okay, so let me uncomment this. All right. And I don't have to read anything in anymore. I already know what all my grades are. So I don't have to read those in, but I can loop through it. Okay. And I can basically come out here and I can just do a write statement that says something like student. So that would be student 1 name. All right. And then we can write that out. So I can put that in here, a plus. names LCV. Pretty much like that. All right, and I can do it again. But let's say grade. And this will be grades. All right. Now, don't need really any of the rest of this. I need the curly brace at the end, but I don't need any of this. All right. Now, what doesn't like? Oh, I said grade and grades. There we go. So let's take a look at that. So again, file, save all, and let's run it. Oh, I think it flipped off the page because I didn't have a read line in there. So let me put that back in. All right. And you can see I didn't do a good job of formatting it, but student one name, Kelly, student one grade, etc. Let's fix that, run it one more time, and then we'll move on. So let's put a \n at the beginning here and a \n at the beginning here. Okay. And let's put two of them here. All right. I think that'll fix it. Yeah. Okay. So we've got the name and the grade. I guess that my tab didn't work very well, but that's not a big thing. You can see that everything that's in here worked. All right. And what we did was we predefined our arrays. All right. We predefined our arrays and they all worked. All right. And let's see. I don't know why that \t didn't work, but I don't care. Okay. So here's where it's typically referred to as we pre-populated our arrays. All right. Now, this will be many chapters in the future, but we're on 8 right now. In chapter 17, we'll talk about files. So imagine that you had 100 grades and somebody had a file for you that had a name and a grade, a name and a grade, a name and a grade, or had 100 names, then 100 grades. You can see how fast you could hopefully go through some of this. You do not put a number here. You let the compiler figure out that there are 1, 2, 3, 4, 5, 6 names, and there are 1, 2, 3, 4, 5, 6 grades. If we leave this one out, I don't think we're going to get an error. I think it's going to put a 0 there, but I'm not positive. So let's just check, see if we get an error or not. All right. Well, it says it is giving us 1. We're getting what's called an index out of range exception. It's another type of exception that you can get. Why? Because it was trying to read 6 things and we only gave it 5. So I guess if I wanted that to be a 0, I'd have to manually put a 0 in there. And then it should work. And you can see it does. All right. And I think the reason that this didn't work is literally it's running stuff together here. So I could have put a \t here and a \t here. It probably would look nicer. Who cares? All right. But you've now seen 3 different ways that you can sit there and work with 6 students and their grades. The first way we did this, we used all scalar variables where everything could only hold 1 value. Then we did it again where we used 2 arrays, and those arrays, okay, were not, they were fixed in size, of course, but we read in the values for them. All right, but if we know the values, again, that's probably the most convenient way of doing it. All right. Now, I mentioned this before, but just so you see this, if you don't give arrays predefined values, all right, the arrays default 0 for numeric, the null character, all right, for a char, false for Boolean, Strings, it doesn't show it in here, but are the empty string. And date string are January 1st of the year 1. Reference types we're going to get to when we get into chapter 12, so I'm not going to talk about those right now. Now, everything that you put into an array is known as an array element. So in other words, going back to here, this is an array element, this is an array element, this is an array element, etc. The way this is typically referred to is names, all right, the name of the array, so names, and then sub, short for subscript. So this is called names sub 0 is Kelly. Names sub 1 is Katie. Names sub 2 is Mark, etc. Now, sometimes that bugs people because if you think about it, what if we had in here, all right, I'm going to just make one up, all right? All right, if I had in here months, all right, so I put months in here, and then I put in January, February, etc. Just imagine that I kept going and I went all the way to December. Just if you would, please, just imagine I kept going. All right, I don't want to type in 12 of them. People go, well, look, now January is 0, February, that's all screwed up. Yeah, that's true. So you come in here and you typically do this. Now January months 0 has nothing in it, but we don't care because months 1 is January, months 2 is February, all the way to months 12, which is December. All right, so it's totally legit to do something like that. All right. Okay. When you create an array, each element, unless you tell it otherwise, is set to a default value. Okay. Now, the other thing about this, again, like I said, I didn't make these rules. I'm just playing the game. Okay. So I already told you this is typically would be referred to as names sub 0. All right. You'll also hear that index 0 of the names array is Kelly. So these are called, they're indexes, they're all sorts of stuff. So this right here, if you can imagine, this is what would be almost as if I said this. Names, I'm going to get rid of it right away. 0 equal Kelly. Because that's the other way that you can do this. All right. What the heck am I talking about? I want to show you that too. All right, so I'm going to take this one that we just did, and I'm going to comment all of this out. Again, I'm not doing this to waste anybody's time, least of all mine. All right, but I could come in here like we did here. All right, like we did here. I'm going to uncomment these. Run. All right, and I could have come in then and said this, names 0 equal Kelly. Copy this. 1, 2, 3, 4, 5. And I'm just going to fill these in. So Katie, Michael, Mark, Mary, Mindy. All right. And then with this, all right, just change all these to grades. Yeah, I'm going to get errors, but we'll fix it in just a second. So that is doing the same thing here as what we're doing here. So a natural question would be, okay, I understand everything you're saying. Why the heck would you want to do this? And the answer is, maybe I declare this at the top of my program, but maybe it's later on in the program when I finally know what the names are or what the grades are or both. So again, it's just another way that you can do the same thing. So what I'm telling you is if I come back in here now and put in this, and let me uncomment everything. All right, and run it, you'll notice, okay, it still looks the same way that it did before. All right, so there are a multiple number of ways that you can do this, is what I'm telling you. All right. And it all depends, for lack of better words, it depends on the circumstance, what you know ahead of time, what you don't know ahead of time, etc. All right, I'm just going to put a space there and a space there. Now I think it finally looks the way I'd like it to look. There we go. All right. Okay. And if it seems to you like, man, you're really going through this slow, I am. In my opinion, for whatever my opinion is or is not worth, this is the hardest chapter we've done thus far. All right. Now, upper bounds of an array. Okay. Well, the upper bound of this array, because it's two different things. This array, I think you'd agree if you look at it, it has 6 elements in it. There are 6 elements in there. Element 0, element 1, 2, 3, 4, and 5. All right. But the upper bound is actually 5. The length of the array is 6, but the upper bound is 5. All right, because you start counting with 0 when you work with arrays. And that is in any language, at least that I know of. All right. So they show some examples in here. Again, they create an array, and again, it's 0, 1, 2, 3. If you were to come in here and do this, again, it would throw an index out of range exception. All right, we're going to go in where eventually we're going to be looking at a couple programs where we'll have to check for things like that. All right. And as mentioned, you can set up arrays of different types of variables. Okay, this is the first time we've seen this word. All right, this word, for those of you who were in the JavaScript class last semester, that word is a no-no. And what I mean is you should never use it. Okay, in here, believe it or not, it almost means the same thing, but yet it doesn't. What var means is, okay, you don't have to come in here and let the system know what kind of an array it is. It sees that there's 4 integers in there, so it says, oh, grades is an integer array. The other big difference, and I should have mentioned this earlier, and I didn't, another really, really, really big difference between arrays in C# and arrays in JavaScript. In JavaScript, you can mix things up. So I can have a name and a salary, etc. In here, names need to have a type associated with them, or a type that can be inferred. So a string array can only hold strings. You try putting a number in there that's not in double quotes, you're going to get an error. Decimal totals can only hold decimal values. If you try putting a string in there, you're going to get an error. All right. So how to work with arrays? They give you some examples in here. Well, I tried doing the same thing. Okay. What we're going to look at when we start tomorrow, unless we get done a little early today, but I don't know if we will or not, but what we'll start with otherwise tomorrow is we're going to write, I'm going to write it, I'll save it for you so you can follow along and write it yourselves or just look at the GitHub repository later. We're going to write 2 different programs when we start tomorrow. The first one is going to generate 100 numbers. They're going to be random numbers. We'll talk about random because that's in this chapter as well. All right. But it's going to generate 100 numbers. Then it's going to give us the opportunity to, like that, sort the numbers in ascending order and sort the numbers in descending order. And we're going to grab the biggest number. We're going to grab the smallest number. We're going to grab the sum of all the numbers. And we're going to grab the average of all the numbers. And the sum and average aren't going to be that different from what you see right here. All arrays have a length property associated with them. That's how many elements are in the array. So when we set up our array, the length again is 6 because we set it up so that it would have 6 names in it. All right. We also set it up so it would have 6 grades in it. If I wanted the sum of all 6 of those grades, I could do it like this. It's kind of a poor way of doing it, but we could do it like that. What the difference between what I did and what's in the book right here is they're not using any loops right there. I used a loop. As you can see, it's very more similar to what's down here. All right. In just a few minutes, you're going to learn about, yet a different kind of for loop that's called a for each loop. That's really more than anything else is meant to work with arrays. And you're going to see that in just a few minutes. But again, notice they're computing a sum here. They're computing an average here. We're going to do a very similar thing. All right. Now, if you can read through this example here, you're starting to understand what this is about. This is creating a new array, and it's going to have 10 integers in it. 0 through 9. So it says grab whatever I currently is, that's our loop control variable, and put it into that location. So location 0 will have a 0, location 1 will have a 1, location 2 will have a 2, all the way up through location 9, which will have a 9. And then they print them out. All right. You really have to write quite a few programs before you start to realize the power of actually utilizing arrays, why they are what they are, why they're important, and why they're used one whole heck of a lot. All right, in programming. And that doesn't matter what the language is. All right, so now they took what was above, where you've got totals, like that, and they put it into a loop. Okay. And then they come down and they put the whole thing into a dialogue. That's no big thing. But again, the sum is in here. Now you should be able to realize this. That's the loop. This decimal average is not in the loop. They really should have put a curly brace before this line and after this line. I wish they would have. All right, I think that's better programming practice. You may or may not agree. All right, so here's these for each loops. Looks a little weird. All right, let's take a look at this example now that's right at the top of your screen. Okay, it's the same example we had before. All right, but now it says for each int num in numbers. Numbers was already set up on the previous page to hold 0 through 9. All right, anything you do with a for each loop, just so you know, you can do using a for loop. All right, this is just an extension of a for loop that was designed to make it a little easier for people to work with. All right, now notice it says for each, and it's got int number in numbers. Where did they come up with number? They're declaring it on the fly. Most of the time when you create an array name, you pluralize it. You put an S on the end. So numbers is the array name. So for example, if you want to iterate through it using a for each loop, It's each number in the numbers array. All right. I mean, it's just kind of common protocol that you do it like that. So int number comes to life right there. And number right there dies as soon as that last curly brace is hit. But what this says is I want to do this for each number in my numbers array. Do you have to use a for each loop? No. Sometimes people, oh, geez, I want to learn the minimum in here. The point is, you see for each loops used a lot in application programming, okay, as a way to iterate through an array. That's all I want to mention. And there's a couple examples of that here. All right, as it says, you can use the for each to access each array element. You can also use it with collections that we'll talk about later on in the chapter. All right, so one thing, I don't know who made up this, but somebody did. If you go and read a lot of C# books, and I have, some of them will say C# does not allow you to have multiple dimension arrays. Like you can't have a 2-dimensional array, you can't have a 3-dimensional array, etc. You can't do that, which is baloney. All right, but 2-dimensional arrays are typically referred to as rectangular arrays. All right, they mean the same thing. You almost never see an array of more than 3 dimensions. I'm not saying it isn't possible. You could have an 80-dimension array. It would be really ugly and terrible to work with, but you could do it. I don't know if I've ever used more. I might have used a 4-dimensional array in some of the stuff I've done, but I've never done anything more than that. And the main reason for that is it's very hard to use something where you can't, I mean, we can't think in 4D. All right. 3D is, something else. So typically, if you can't conceptualize it in your mind, most people don't use it. So for creating a rectangular array, as I mentioned to you, it's in row column order. So the first value that's in there is the row that you're working with. The second value that's in there is the column that you're working with. So they show some examples of this right here. Now it looks pretty ugly. Notice when you do this, when you do it like this, yeah, you leave, since there's 2 dimensions, you need the comma in there. If you had a 3-dimensional array and you were going to do it like that, you'd have 2 commas in there. Not only that, you can always tell how many elements are in the array by multiplying the number of rows by the number of columns. So there's going to be 6 elements in that array. All right, it's a 3x2 array. And I say, no, there's not 6 there. No, this is a 4x4. So there's 16 elements in there. All right, so you can set up arrays like this. Again, row 0, column 0, row 0, column 1, row 0, column 2. You're still counting and you're starting each of these with a 0. All right, and again, that hopefully at least makes at least some sense to you. All right. Now, if you know the values ahead of time, you'll typically put them in like this. All right, this is a 3x2 array. Again, row 0, column 0 type of an idea. Actually, that'd be row 0, column 0. I don't even know how you'd say that exactly. Okay. Here's another one with strings. Now, we're going to see examples of this as we go on in the book. And what they're going to do is they're going to call this the book's code, and they're going to call this the book's title. So the code is C#, the title is Murach's C#. The code is Java, the title is Murach's Java Programming. The code is ASP MVC, the title is Murach's ASP.NET MVC, etc. Okay. And here it says, here's another way you can create that as well. All right, using the word var. I don't know what this buys you. That's just me, but that, I've just done it like this forever. So as it says here, a rectangular array uses two indexes, rows and columns, and it's done in row column order. I got asked by a student many years ago. They said, okay, I understand what you mean by row column order. Okay, not a problem. But I've worked with Excel my whole life, and I'm used to working with column row order. Could I literally set up an array and put it in column row order? The answer is yes. That said, you're going to screw with people because they're not going to be able to understand that, because in programmatic language, it's always in row column order. All right. And again, although it's rarely necessary, you can extend the two-dimensional syntax to work with arrays of more than 2 dimensions. All right. So working with rectangular arrays, let's just take a look at the example that's in here. All right. It looks pretty ugly, to be honest with you. Most of the work that we're going to do in here, virtually all of it, will be in single dimension arrays. It's not that I don't think that people can't handle it. It's just that the exercises and stuff that we are asked to do, by and large, almost always, if not always, involve single dimension arrays. That said, I'm not saying that multiple dimension arrays don't have their place. All right. It just depends on the problem that you're trying to solve. Okay. All right. Okay. Now the array class, I already showed that to you. We didn't really look at it at all. All right. So I really didn't show you that, but there is an entire array class that has, as you saw, a very big number of methods in it. All right, we're going to look at all of these. All right, such as the sort method, to sort things in ascending order. All right. Even though there's other ways of doing it, once you use the sort method to put them in ascending order, there's another method that's called reverse. So if you do a sort, then a reverse, then you're putting your array in descending order. Then there's a binary search. Now, for a binary search to work, your thing has to be in order. It has to be in order, in ascending order. So in other words, let's say I had a series of numbers. Just to show you this real quick. I'm not trying to waste your time, but it's kind of important that you see this. All right. So let me make this bigger. That's too big, but that's okay. And let's just come up with, I don't know, I'm going to come up with 5 numbers. Now, you're all smart enough that if I said, is the number 15 in there, you could look and go, no, but you're not the computer. All right. It's kind of like a phone book. All right. And I know phone books are not really in jive anymore, and they were more when I was your age. But you could open up a phone book, and if I knew somebody's name and I knew their name was John Lang, I'd look in the L's. In other words, it would have to be in sorted order. If I had names in the phone book and you just put a bunch of names in there that were in random order, it would be very hard to find something. Now, for the computer, though, if I take this and I change it so I've got 8, then 11, all right, then 45, then 67, and then 93, now I can perform what's known as a binary search. All right. What do I mean? Well, you kind of go into the middle. Okay. And believe it or not, that is in the middle because there's 2 values above it and 2 below it. All right. And you say, is that the number you're looking for? The answer is no. And then you say, okay, is the number I'm looking for higher or lower than that number? It is lower. So I already know those numbers, They're out of it. It can't be though, any of those. All right, so I've only got 2 numbers left to search. All right, and even though this isn't half, that's what you look for. So you look right there and you say, okay, higher or lower. All right, well, it's the number's higher. You can't go any higher because that's the highest number you got left. So you know the number's not there. On the other hand, with this, if let's say I was searching for 67, I'd again look here. All right, and I'd say, is it higher or lower? It's higher, so I would look in here. All right, now I've only got 2 left, and I'd say, is it this number? And if it's not, then I say, is it this number? In this case, it is. But if it wasn't there, I'd know the number wasn't in there. It's not the same thing, but I've given this example before. I remember this. This was many years ago. All right. If you've ever watched the TV show, The Price is Right, for about the last 20 years, Drew Carey has been host. Before Drew Carey was the host, there was a host named Bob Barker. And I remember watching one summer, I was home and watching, and this woman was trying to win a refrigerator. All right. And it was about $800. I don't know, something like that. Let's just say it was 800. And she said 500. And he said higher. And she said 600. And he said higher. 700, higher. And then she started saying like 701, 702. And I thought, lady, you aren't going to win because you only had a minute to try to guess the price. But it's like anything else. You know, I'll tell my kids, we used to play this when they were little kids. They're not anymore. But I'd say, I'm thinking of a number between 1 and 100. All right. And then they would, after they never figured out, they would just shout out random numbers. But if they would have ever said to me, 70, if I said no, they would have said, is it higher than 70 or lower than 70? I would have told them. All right, that's kind of what you're doing in here. So when we go through these examples tomorrow, we'll show how to perform a binary search. Okay. So here are some of the properties that you'll work with in an array. Okay. I'm not saying that you're going to use the get length and the get upper bound a lot, but you might. The length property, you use that in almost all the time when you are working with loops. All right, to know how far to go with an array, for example. The copy is really neat. It doesn't sound like it is. It used to be, if you wanted to copy one array to another array, you had to take your first array, put it into a loop, and one at a time copy things from one array into the other array. And it doesn't sound like much, but it was a pain in the butt to do. Well, now there actually is a copy method that you can use, and we'll look at that, just not right now. The binary search and the sort, as I mentioned, will work. We'll work with in the future. And again, I already said this. The binary search only works when the array is in ascending order. If it's not, you run the sort method on it first. All right, then it'll be in ascending order. This is on how to copy arrays. And they're going to show you a bunch of ways that you can do it. All right, now I do want to mention something. All right, and that is this. I'm going to just very quickly show you something in here. Let me get rid of this. You remember, or hopefully you remember, we went through a couple of examples like this a week or so ago. And that is when we came in and did this. If we said int x equal 10, int y equals 17, int sum equals add 2 x, y. One of the things that was mentioned to you during that time is when you pass these values in, they're passed by copy. And you even learned that if we wanted to be able to change them, we put ref in there or we put out in there. All right, you learned that before. We went over that a while back. Now, the reason I'm telling you that is, let's suppose in here I've got this int numbers, try that again, int bracket numbers equal, and I'm just going to put 3 numbers in here, 1, 2, 3, like that. Whoops, that needs to be a curly. All right. So imagine that I've done that. Okay, and now I want to pass this entire array in. When I pass it in, I use this numbers. That passes the array in. But it's a big but. No pun intended, no joke intended. All right. You always pass in arrays by ref. All right. They're always. If you pass an entire array into a method, it's passed in by ref, meaning if you change any of the values, they are permanently changed. If you pass in, like if I did this, if I just passed in this, which would pass in the 1, that's still passed by value. This passes the address. So any changes you make, okay, also in here. So if later on in here, I was going to write private void, oh, I guess it'd be an int add 2. Okay, I've got to do this. I've got to go int bracket numbers, like that. I have to let the system know that it is working with an array. It's not smart enough otherwise to be able to figure that out. All right. So this is what they're saying in here. An array is a reference or ref type. All right. All right. And again, I'm not going to go through those copy examples. Take a look at them. All right. You may find them very easy to work with. You may find them very hard to work with. We're going to do very little to nothing with copying stuff with arrays. All right. How to code methods that work with arrays. Again, you'll notice in here, private decimal. Okay. So this says that we're returning an array. All right. We are returning an array. There we're returning rates. Rates was defined as an array. So you can pass arrays in to a method. You can return arrays from a method. Totally fine. You can both pass an array into a method and return an array out of a method. You can do both. All right. It's whatever you want to or need to do. Now, just so you know, I am pretty much purposely not going over a lot of these examples in depth because I don't want to confuse people. All right. And again, I may or may not have mentioned this before, but typically when we get to this chapter, there's at least some people who are like, I have no idea what the heck these things are doing. That's why tomorrow we're going to write the same program twice. We're going to write it first as a console application. Then we're going to go back and virtually rewrite the whole thing as a GUI application. All right. And we'll take our time doing both. I've literally got probably somewhere around 12 examples that I want to be able to go over between Tuesday and Wednesday and Thursday. And when we go over those, we're going to go over them slowly on purpose. All right. All right. Now, there's a special keyword you can use with arrays that's called params. All right. Do they show an example of a param in here? Yes, they do. And params can actually be used in more than one way. All right. I want to show you in here, okay, quickly why params is important. All right. I want to say this again. I want to show you quickly in here why working with params is important. All right. So I'm going to come in here and I could put it in our program, but I'm not going to write an entire program. So, all right, let me just bring this up here. Okay. All right. And I'm going to come in and I'm going to do this. I'm going to write in here private. Int is fine. Let's see. I'm trying to think of one that would work really well in here. We'll do an average. All right. So we'll call it average. And I'm going to put in here params. In fact, we're going to make this a decimal. It's a problem when I try to think outside the box a little bit. So I'm going to put in here params, int, bracket, numbers. Okay. And then we'll put in here, let's see, it's going to be an integer array. So int total, and we'll just set that up to 0. All right. And then I'm going to put a for each in here. And I'll put in here int num in numbers. Total plus equal num. Now this might make no sense. We're going to go over it in just a second. All right. So I'm going to say return. Total divided by numbers dot length. All right. The problem is it's not going to return a decimal because I'm working with ints. So I will cast that as a decimal. All right. I expect little to none of what I just did to make sense. So I'm going to give you an example of how it's used, but I want to make this a little bit smaller here. So let's make it about 28. I know that's quite a bit smaller, but that's fine. Okay. All right. What is this? Why am I showing it to you? Well, params, for lack of better words, this means variable length. I want to say that again. This means variable length. All right. Who cares? I want to just show you why you should care. I'm going to come in here and I'm going to put a private void. In fact, I guess we use static in here. So, but that's fine. We'll just leave it private void main. And inside of main right here, inside of main, I'm going to create 3 arrays. All right, I'm going to pre-populate them because now you know how to do that. So I'm going to say int bracket ARR array 1 equal 1, 2, 3. All right, int bracket ARR2 equal 4, 5, 6, 7. I know what I'm doing. Give me a second. Int bracket ARR3 equal 8, 9, 10, 11, 12. Hopefully what you notice in here is I have 3 integer arrays. The first integer array has 3 elements in it, element 0, element 1, and element 2. The second array, ARR2, has 4 elements in it, element 0, element 1, element 2, and element 3. The third array has 5 elements in it. Element 0 is 8, element 1 is 9, element 2 is 10, element 3 is 11, and element 4 is 12. Hopefully, all of that makes sense. All right, so why the heck are you showing me this, Jeff? Well, I'm going to come in here now and I'm going to create 3 variables. Decimal, I'm going to call this ARR1 AVG equal average, and I'm going to pass into it ARR1. And I'm just going to copy this down. This will be ARR2 average and ARR3 average. And this will be a 2, and this will be a 3. Whoops. For lack of better words, params here means it'll handle a random number of values. So the first time we call this, it's going to add together 3 numbers. The second time we call this, it's going to add together 4 numbers. And the third time we do this, okay, it's going to put in 5 numbers. So this value in here is going to either be 1 plus 2 plus 3, which is 6, divided by 3 is going to give you 2.0. This 4 plus 5 plus 6 plus 7 is going to be 9 and 7, 9 rather, and 6 is 15 and 7 is 22 divided by 4. So that's going to give you 5.5. And this 8 and 9 is 17, and 10 is 27, and 11 is 39, 8, 9, 17, 27, 38, and 12 is 50. Divide that by 5 will give you 10.0. The bottom line is this. This will handle an array of integers of any size. All right, I want to say that again. It'll handle an array of any size. The only thing it won't handle, and I think you could do this, I don't know why you would, but I think it would work if you said int bracket ARR1 equal, and you did this. I think you can do that. Now, if you said to me, okay, you can do that, why the heck would you want to? I have no idea. But there's nothing in there. So you might want to change this to have it say something like, if numbers dot length is greater than, well, just we could say probably not equal to 0. I would put this in parens. Question mark. Remember that ternary operator, the question mark colon. So I'm going to come down here, whoops, and I'll say colon 0.0. And what that means is, as long as I've got something in the curly braces, add it up. But if I don't have anything in the curly braces, just return 0. I think that would work without any problem. All right. But the key takeaway again on this is params means variable length. You have to understand that. All right. And I'll save this one too. Put that out there a little bit later. All right. I'm going to go until when we took a break at 9 till 9:10. So I'll go till about 10:10. All right. Okay. If you haven't liked this so far, you'll like this even less. This is called the null conditional operator. And what is it? Well, if you take a look right here, you're using a question mark. Get used to using that question mark, all right, when you want to allow nulls in C#. Now, the question mark, and sometimes it's an exclamation point, depending on where it's used, how it's used, etc. You'll be using this, those of you who take you all, eventually, when you take the AWD1100 class, all right, which is the class where you write web applications using C#, and you use it using something called ASP.NET. Don't worry about it for now. But the point is, and what they're trying to show you in here, if you did this, which is legal, totally legal, if you did that, and you said string bracket initials equal null, like that, then you tried to read something out of there. So you tried to read something out of null, you'd get what's called a null reference exception. There are different ways that you can handle that. One way that you can handle that, one way, is to check and say only do this if initials is not null. And that'll work. All right. Or you can do it like this. And what this says is, hey, I'm going to allow nulls. All right. That's what this is saying. But this is saying here, only take the first thing in the array and convert it to uppercase if there is a first thing to convert. So as they mention here down below in the description, if you try to access a member or element of an object that contains a null value, you get a null reference exception. One way to do this is to use an if statement. All right. Again, it's kind of like what we did with exceptions. Before we went into exceptions, we handle everything with if statements. And you can do that here as well. As they say, an easier way, and easier is relative. You may or may not think it's an easier way, but the null conditional operator is that question mark. As it says, it checks for a null, and if it finds a null, it says, okay, we're basically dead in the water. There's nothing else to do. All right. Then they say, because the null conditional operator can cause a null value to be returned, the variable is that it's assigned to must be defined as a nullable type. That's why this says here it's a nullable type. This says to only do this if what we're checking is null. And you'll notice there's a question mark before it and after it. You can get into some very ugly lines of code by using this. All right. And it says we're going to even come back and look at it a little bit more in a later section of the book. All right. I want to go just a couple more pages and get to where we're going to be, where we talk about lists, and then we'll take our break. All right. Some of the next thing that you're going to see in here, either they borrowed from JavaScript or JavaScript borrowed from them. All right. I don't know. I don't care. But when you are working with a range operator, you can use 3 dots, and you can do some of the same stuff again in JavaScript. All right. Now, why would you want to do this? It just can result in a little less code. All right. So they have 2, 3, 4. There's 8 different elements in here. Hopefully everybody can see that. Element 0, element 1, element 2, element 3, element 4, element 5, element 6, and element 7. Okay. And then they're saying here, if you go 0.3, that says start with 0 and do 3 of them, which would be 0, 1, and 2. That's the same thing as doing ... 3, which says start at the beginning. So again, 0, 1, 2. So this is where you start from. This is how many you want to iterate through. This says start with 6 and go as long as you have things. So 0, 1, 2, 3, 4, 5, 6. Well, there's only 2. So there's 6 and 7. All right. If you want to go through everything, you can put a ... there. So there's different ways that this can be used. All right. You can write a shortcut in some of your code by using this range operator. And that's pretty much what they're going to say in here. Now, look at this. You'll notice that the first 2 things in here say with C# 8.0 and later. Now, 1 or 2 of you have asked me about this, but remember, what I've been doing by and large for most of the semester is we've been choosing the .NET framework, whether we're doing a console app or whether we're doing a GUI app. And if we use the .NET framework, we're using version 4.7.2. So we can't use stuff with version 8. However, if you use the Windows Forms app without the .NET framework or the console app without the .NET framework, then you can, all right, use this stuff that they mentioned for version 8.0 and later. All right. The next thing that's in here, we're just got a page or two and then we're taking our break. All right. Is this list pattern. So we'll look at this and then we're with collections. So we'll take another break. All right. When you work with patterns, they're just that. So this pattern right here says if quantity is 100 or is 200 or is 300 or is 400, that's true. All right, because it's listing all of them. This one is false because they listed 400 twice. There's no 300 in there, so it's false. This is false because you left off 400. This one is true because it replaced this discard value with whatever your last thing is, 400. All right, so it's true. Not only that, notice you can put checks in here. This can provide a way for you to do a little bit more work with working with ranges and other stuff that's in here. Now, that said, that's pretty ugly when you look at this one here. But these are called list patterns. Now, it doesn't mention in here that it's version 8 and above. I always have looked at it in this textbook, which means that we should be able to use it even in our .NET framework apps, I believe. I don't know if I've ever used a list pattern or a slice pattern or a discard pattern that they show in here. Okay, I'm not sure exactly what it's buying you to use. To me, and this is my opinion, again, as I've said before, no kidding, no jokes, all kidding aside, whatever my opinion is worth. And that is that it's confusing to me to use this stuff. When you're first learning something, if you come across stuff that is designed to make your life easier, sometimes that stuff will be confusing. So I tend not to use it until I've got more experience with it. All right, but if you want to read more about that, as it says in here, you can. All right. So before we start with collections, we're at 10:13. Let's come back, please. Let's make it 10:25. I will see you then, and we'll finish up the chapter at that time. I will be right back. All right, it is 10:25, so I'm going to start back up. And the rest of the chapter, like I said, the last 15 to 20 pages is on collections. And as they mentioned, like an array, a collection can hold one or more elements, but unlike an array, they don't have a fixed size. All right. Rather, that size is going to automatically be increased when elements are added to it. So technically, it never runs out of space. Now, they give another word in here. It says, in other words, collections are mutable. What that means is the size of an array that we just looked at is immutable, meaning that while the program is running, you cannot change the size of an array. But if you have a collection and it fills up, its size is automatically changed. And that's what they're saying in here, that it is mutable. They're going to talk about 5 types of collections in here. We're going to concentrate almost solely on lists, but we will talk a little bit about sorted lists, queues, stacks, and array lists as well. And as they mentioned, although .NET provides for other collections, these are the ones that you'd use the most often. All right. Now it says .NET provides 2 types of collection classes. First, it includes collection classes that can store any type of object. So they're not typed. And if you say, I don't know what that means, well, if you say int age equal 18, age is typed. There is a type associated with it. All right. If something is untyped, all right, then you can store different types of things in it. You typically don't want to use those because they can run into some weird types of errors. All right. So it says the second type prevents errors like this by using features known as generic that allow you to create typed collections. So again, you've got both typed and you've got untyped. The reason that these are important is using these. All right. In order to use these, you will have to add different using statements to the top of your program. And that's what they're saying in here. All right. That you will be using either system.collections or system.collections.generic. So if you're going to use typed collections that only store a certain data type, which is probably what you'd use most often, you're going to put a using in there that says using system.collections.generic. If you're going to allow for untyped, then you only need the using system.collections. All right, these are the ones basically that they're going to talk about in here. So we're going to talk the most about list. All right, we'll look at an array list as well. We'll look at all of these, but not really in a lot of detail. Let me just mention to you before we go into it, let's talk very quickly, because this is all I'm going to really say about them, about the last two. And that's a queue and a stack. All right. Imagine that I know things have changed over time, so bear with me with my analogy here. All right. I know that today, for example, if you're going to a movie, you can go out, you can buy your tickets online, etc. But let's say you don't do that. So let's say you go to a movie theater and you want to buy a ticket for yourself to see a movie. I don't care what the theater is or where the movie is, it doesn't matter. But let's say that there's 5 people in front of you in line, meaning that you're the 6th person in line. You are in a queue. All right. In a queue, it's called something it's known as being FIFO. So the first in is the first out. In other words, the 5 people who are in front of you are going to get serviced before you do. That's a typical queue. All right. As far as a stack goes, because this is the example that is given all the time, and I don't know if it's a great one or a good one or not, but if you remember, all right, at least this is the way it was when I was in high school, all right, that you had your choice of bringing your own lunch or you could take a hot lunch. If you took a hot lunch, you were expected to put your, your lunch, all of it on a tray. If you were out of trays and the lunch person came in and put in a whole bunch of trays, they put them down on that little thing that was kind of like, it kind of like had a spring in it. But the point is, the last tray that was put in there would be the first one that you would use. So that's kind of the opposite, whereas a queue is a FIFO, first in, first out. A stack is a LIFO, last in, first out. And that's really, with queues and stacks, that's all I want to say about them, at least for this at this time. All right. So notice that when you use the typed stuff like this, it's a little more complicated because you have to let it know this T that's in there is the type that you're using. All right. And it can be a little bit confusing. So this would be a list, for example, you'd put in here int or decimal or bool or something else. Okay. Now you can do the untyped, but the untyped can be very difficult because there's a lot more checking that you have to do. And a lot of this, there's still checking that has to be done, but it's automated. So if I say it's a list of ints and somebody goes in there and puts in a Boolean or puts in a string or even puts in a decimal or double, the program breaks automatically. All right. So as they mention here, a collection then, a collection is an object that can hold one or more elements. All right. The collection classes in the systems.collection.generic use generics. So in other words, they work with typed classes. So they only store that particular type, which has to go in those angle brackets. The collection classes in the system.collections allow you to use untyped, where you can store virtually anything in there. But again, it can be very problematic. All right. So as it says here, the next figure shows the differences between typed and untyped. And as it says, it shows that typed, the ones that we're going to basically be using, have two distinct advantages over untyped. First, they automatically check the type of each element at compile time. So in other words, you're not going to get a runtime error from putting in a decimal value in with a list of ints because it'll be checked before that. Second, as it says, they reduce the amount of casting that's needed when you are retrieving items. What does that mean? That means that if instead of using typed, if you use untyped, because it allows you to have more possibilities, that you might have more casting that you have to do. Remember, with casting, what you're doing is you are putting a type inside of parentheses. All right, so they show some examples here on the next page. So again, notice again with untyped, it's using system.collections. Whereas with typed, it's using system.collections.numeric. So here's an array list. And notice you're adding numbers to it. But then, boom, you come in here and you add in a string. And as it says, it'll compile. But when you run it, okay, the system is, these are numbers. This must be an array list of ints. Oh, there's a string that you cannot convert. Had this been, let's say, inside of these double quotes, had this been like 43, it might have tried or might have been able to convert it, but test it cannot convert. All right. So they're going through this, and it says the cast is required. Well, this is going to break when it gets to right here. All right, because it's going right there. Because when it tries to cast the word test to an integer, it's going to break. All right. But if you try doing a similar type of thing with a type collection, it won't work. It won't even compile. All right. So these are considered safer to use. All right. Okay. So the next 2 or 4, something like that, pages are on lists. And you'll notice with the list, this T in here again stands for type. These are typed collections. All right. It says the most common type of typed collection is a list. All right. So let's take a look at an example. And that's right here. When you do this right there, okay, list, the type that's going to be held in there, the name of the list equals new list of that same type, then you need parentheses. If you leave the parentheses empty, the size defaults. So in this case, titles would default to 16. So would prices. Here, you've given it a default size. So it's going to start with 3. So if this fills up with 16 or this one with 16, boom, it doubles to 32. If this one fills up with 3, boom, it doubles to 6. All right. Now, stuff that you can do with lists. I'm not going to read these to you. All right. But add and remove are probably the most powerful. They allow you to add something by default to the end of a list or remove something by default from the front or beginning of the list. If you don't want to add to the end of the list, if you want to add, all right, someplace else, you can use insert. All right. If you want to remove and you don't want to remove the first occurrence, you can use remove at. All right. And you'll notice it also supports a sort, and it supports you using a binary search. Now, I showed you this earlier. We went in here and we looked at both the array class and quickly. We also looked at the list class. All right. And again, to find this, and I can give you the URL if you want it, but all I did was I went out to learn.microsoft.com, and in the search bar, I put in either listing of C# list methods or listing of C# array methods. All right. Nothing really, I don't think at least, surprising in there, for lack of better words. All right. So notice it there again. Notice you can see it. It's what I told you. Once you put in 3 names in this list of last names, so once you put in Bame, the Lambda, or whatever you pronounce it, and Murach, before you can put in Taylor, etc., it automatically doubles from 3 to 6. Once you put in Taylor and Balon and McCoy, it automatically doubles to 12. That's why, as it says in the description here, a list is a collection that automatically adjusts its capacity to accommodate new elements. All right. And they give some examples in here all right? They give some examples in here, and in those new examples, or in those examples, they show you some of the stuff that you can do, all right? Now, I am going to talk to my counterparts at the St. Louis campus. When you take your Chapter 8 test, which will either be Friday or next Tuesday, probably next Tuesday, but we'll see. All right. When you take your Chapter 8 test, the one that has been pre-written for me, there's two problems on it. The first example has you use arrays. All right. And we're actually going to do a problem very similar to the test problem in class. The second problem, I don't know where the hell they wrote it from, who wrote it, or why they wrote it, but in my humble opinion, it has nothing to do with arrays or lists. So what I plan on doing is replacing that second problem with a different problem that will probably use a list. All right. I mean, if we're taking the time to talk about this, it's something that you should be tested on. So as you can see in here, there's the insert, there's the remove. So the insert gives you a new first element. The remove at with a 1 in there. If it was a remove at 0, it would remove the first element. But since it's a remove at 1, it's removing the second element. And they show you kind of an after picture of what's going on in here. All right. All right. It says you can also implement a typed collection by using the sorted list class, which defines a sorted list. As it says, it's useful when you need to look up something based on a key value. For instance, it says a sorted list, if, for example, if it consists of item numbers and unit prices, all right, this is really one, at least, of the first times that we have looked in here at things that are known as key value pairs. All right. Believe it or not, you may know this, you may not know this, but when you came into Rankin Technical College, you were given some kind of a Rankin ID number. Usually it's 6 digits long and it starts with a 1. I've got one also. That's a key. So if somebody knew my key, they could say, oh, the value of that is Jeff Scott, type of an idea. All right. But much of the work that you're going to end up doing in your second year of the program will work with key values. All right. So as it says, the keys in the sorted list, along with their values, are typically called key value pairs. That's why previously, and I didn't mention it, but when we started to look at this, and not there, well, it was in here. There it is. That's the key of KV that they say in here. That's the key value. All right. Now, can you work with lists without having to have a sorted list? In other words, are these things mandatory? The answer is of course not. No, they're not mandatory. There's something that can help you depending on the situation. Now, if we work on a problem on a test, for example, and I put a list in there, I'm not going to sit there and say, hey, how do I screw with these people to make everybody fail? I want just the opposite to happen. All right. So we're not going to be doing anything really with a sorted list is what I'm telling you. But if you do, here's some of the other things that you can work with. And you'll notice that some of the things that are in here work with both the key and the value. Some work with just the key. Some work with just the value. All right. Okay. And here, what they were able to do is by using the keys, they put these into ascending order based on the last name. Okay, so as it says, you can use the key for any item to look up the value for that item. All right. And most people, when you think about it, you know, your key probably the way most people look you up is with your social security number. All right. So as it says, again, the keys or the items, I should say, in a sorted list are created from a key value pair structure. Okay. All right. So queues and stacks, we already talked about. And again, they mentioned as I did that a queue is a FIFO collection. It's a first in, first out, whereas a stack is a LIFO. Okay. In other words, a stack is a last in, first out. Okay. Now, when you work with this stuff, you look at this, you're like, what the heck would peak be? Well, we'll talk about it in a second. All right, when you work with a queue, as it says, count is how many. So that would be, for example, how many people were in line. Not where you are in line, but how many people were in line, period. That'd be the count. NQ, as it says, removes from the end of the queue. DQ, all right, I'm sorry, NQ adds it to the end of the queue. So it's like a new person, all right, comes in line. So they're behind you now. DQ is the first person who's in line is done. So they get removed. There's clear, as it says, which removes everything from the queue. And there's peak. And peak is typically known as a look ahead. So it lets you peek and show you what the next thing in the queue is. All right, here's the stack. So whereas you NQ and DQ, okay, when you're working with a queue, you push and you pop when you work with a stack. When you push, it's like the cafeteria person coming in and pushing down those list of trays. When you pop, it's like grabbing the top tray. And then again, there's a clear and a peak, which are used in the same way. All right, the last thing that's discussed in here, because we're almost at the end of the chapter, is how to work with an array list. And it says, although you'll probably want to use type lists whenever possible, the last figure in the chapter shows you how to work with an array list. Why? Because again, as mentioned, it's probably the most common untyped collection. So a list is the most common typed collection, and an array list is the most common typed or most common untyped collection. All right, it says this should illustrate the similarities and the differences between the two. For the most part, an array list works like a list. But since it defines an untyped collection, there are differences. First, as mentioned here, when you create an object from an array list class, you don't define the type within angle brackets. Instead, you store it as what's called an object type. And there's a couple terms for this. It says the process of putting a value in an object is known as boxing, and taking it out is known as unboxing. All right. Second, as mentioned here, when you retrieve an element from an array list, you must cast the object type to the appropriate data type. Okay, so there's casting that has to be done. And it says most of the rest of the examples work like the ones you just saw. All right. Now, when I work with these, I use lists. I don't know if I've ever used an array list for anything. I don't mean at all to demean them or to say they're not important. I'm just saying in all the stuff I've ever done. Okay, so I think what we're going to do all right, is rather than finish here, we're going to write one program, or I'm going to write one program, all right? And I want to show you a couple different things in here. Now, the program I'm going to write, it's not real long, it's not real short, but I'll write it. And why? I want to write this now so we can get the console part of it out of the way. So when I start tomorrow, we'll go in and we'll do a GUI project right away. All right. So what I'm going to do is I'm going to come in here. These are going to be some practice problems. All right. I think I already have a thing in here called practice, but I don't know where it is. So I'm going to make a new folder. I'm just going to call it practice 8. Hopefully I don't have one with that name, but we'll find out. So practice, how about practice dash chapter 808? There. Okay. And I'm going to come in and I'm going to start up a new session of Visual Studio. And I am going to create a new project. It will be a consoleapp.net framework. And I am going to put it into this folder called Practice Chapter 8. All right. And we will take the solution name. We'll just call it Practice 08. All right. Okay. So create. Oh, I didn't want, I called it console app. I didn't change the name. Let's see if we can change the name here. I'm going to right mouse click on it and do a rename. And I want to change this. So I'm going to call this, I can call it whatever I want. This is going to be basically a number array program. So I'm going to call this number array console. And again, it says, do you want to change it everywhere? Yes, I do. So I hit enter and you can see it changed the name there. It didn't change it up here. I thought maybe it would, but it didn't. Okay, I think we'll be fine. All right. So what do we want to do here? Okay. Well, the first thing that we want to do is I want to create 25 random numbers. Okay, I want to say that again. I want to create 25 random numbers and I'm going to stick them into an array. Saying that one more time. I'm going to create 25 random numbers and stick them in an array. So I'm going to start here by saying, as always, declare and initialize program constants. Be just one constant. So I'm going to say const int size. Please, those of you who are not doing it, take your constants and make them all uppercased. All right, and I'm going to set that equal to 25. Then I'm also going to declare and initialize our class variables. Remember, again, a class variable is something we create outside of the domain or outside of any method. And I'm going to have a couple of these. All right, since I'm working with main and main is static, I'm going to make these static. So I'm going to say static int bracket, and we'll call it numbers equals new int of type size. So that'll give me a 25 member array that by default, all 25 members are 0. All right. The other thing I'm going to do, I don't have to do this. In fact, I'm not going to. I was going to make another variable in here for the sum, but I'm not going to even do that. I'll do it a different way. So this is what we have. And inside of main, I want to put it in an infinite loop. What do I mean? I want to run this over and over and over and over and over and over and over again. So I've got two ways that I can do this. I can put it into an infinite loop, meaning that eventually when I want to stop running it, I'll have to click the X in the upper right-hand corner. Or I could do a thing where I run it and then I can ask the user if they want to run it again. But I'm just gonna cheese out and just say while 1 equal 1, which is always true. All right, you know that 1 is always equal to 1. So I'm going to put it in as an infinite loop. And I'm going to write in here 7 different methods. All right, and I'm going to call them, so I'm going to get 7 errors, but I'm going to take and comment out the bottom 6 write the first one, then uncomment the second one and write that one, etc. So I'm going to call initialize array. All right, then I'm going to call sort array ascending. Then I'm going to call sort array descending. Then I'm going to call get smallest array element. Then I'm going to call get largest array element. Then I'm going to call get sum of array elements. And finally, I'm going to call get average of array elements. Now, hopefully, those are written in a way that makes enough sense that you understand what each one is going to do. All right. So when I write initialize array, what I want to do down here is I want to fill that array up with 25 random numbers between 1 and 100. All right. Let's pretend they're test scores. All right. So create 25 random test scores between, we'll say 0 and 100. That's not the way I did it, but that's fine. That's what this method is supposed to be doing. So it has to be static because it's working with main, void, and it's initialize array. All right. So the first thing I want to do is make it so I can start getting random numbers. So I'm going to do what's called seed the rand. All right, that means get it ready to be able to do this. So I'm going to use random. I like to call mine RAND. They call theirs RND. It's no biggie. You can call it Ralph if you want. It doesn't matter. All right. So that's seeding the rand. Now I'm going to come in and generate 25 random numbers between 0 and 100. And there's two ways that I can do this. I'm going to show you them both, not to confuse you, but just so you see them both. So I'm going to put this into a loop for int. I always use again LCV for loop control variable equals 0. LCV less than. I can use size, or since I have an array, I could say numbers.length. Either one would work. I'm just going to use size. Yep, size. And then I'll say plus LCV. All right, now I'm going to show you two different ways that we could do this. All right, so the first is numbers LCV equals rand.next. I have to give it a beginning value, which is 0, and I have to give it one more than the end value. So that will generate 25 random numbers between 0 and 100. Why do I have to put 101 in there? Remember that when you run a random number function, you get a number greater than or equal to 0, but less than this number. If I put 100 in there, it would only give me numbers between 0 and 99. The other way I could do this if I wanted to, don't have to, but I could, is I could come in here and I could come up where I've got my constants. So I'll have to put an S in there. And I can say const int min test score equals 0, const int max test score equals 100. All right. Some people would argue and say, yeah, that's much more descriptive. It's much easier for people to understand. Then in here, I would change this one to, this would be min test score. And this, even though you probably wouldn't need parens, I would use them anyway, and say max test score plus 1. All right. And looks like I'm missing a paren. There we go. Either one of those ways would work. And there isn't one that's better than the other one. There really and truly isn't. All right. Now, I'm going to write one more method in here so you can see what's happening all the time. And that's going to be called display array. And again, that's what I'm going to write next. Okay. So I've now filled up the array with 25 random numbers. In fact, I'm not even going to call it from there. I'm going to call it from right here. So I'm going to call display array, which should just show me the 25 numbers. That's it. All right. And it might be kind of nice to put a little message in here. So I'll do that. I don't need any of these, as you know, but I will put in my old trick of using static system.console like that. All right. So before I do this, I'll put in a write line that will say display the 25 numbers in their original order. Okay. And then we will call display array. Now, of course, I'm getting the error because we haven't written display array yet. Let's write that right now. All right. It's pretty small. So notice the IntelliSense has already got that in there for me. Okay. So again, I want to display the 25 random numbers. So just like before, I'm going to put it in a for loop. So I'll grab those two lines just so you don't have to watch me type. All right. But now what do I want to do? Well, I want to display them. Okay. So I'll write them right on the screen. I'll do a write, and I will display the current number, which is numbers LCV. And then after it, I'll put a blank space. So if I had, again, in here, I'm going to have 25 numbers, but imagine I had 5. It would say something like 55 space, 43 space, 91 space, 87 space, 56 space, something like that. All right. Let's see if at least right now it works. So I'm going to do a file, save all, and I'm going to run this. Now, I was going to say it might go off the screen. Well, it ain't doing that. But the problem is it's running, and then it's running again, and then it's running again, and then it's running again. That's what it's doing. So it's actually working. So what I'm going to put in here is after it displays this, I'm going to put in a read line. All right. And that's going to allow it to stop, so I can just stop it after one run. So there it is. There's my 25 numbers. All right. Notice if I do that and hit enter, now I get 25 different numbers. They are different. If I do it again, 25 different numbers. So it's working right now. All right. That's good. So far, it's done what I've asked it to do. Okay. All right. The next thing in here is sort array ascending. Okay. I'll get an error because I'm calling a function I haven't written yet. So let's write that right now. Static void sort array ascending. Well, we've got an array, and that array is called numbers. So array.sort numbers. Oops, I didn't spell array right. It's a member of the array class that I showed you before, and it's the sort method. And we're running it on our numbers array. All right. So we've got that now. I'm going to put another read line in here, and I'm going to put a bunch of these in here as we go, just so I can stop at certain points. And now I'm going to say, right, here is the array in ascending order. All right. Now, the good news is I've already got a routine that I wrote called display array. So now I can just tell it to display the array. So let's see if this works. All right. So file, save all. So there's our 25 numbers. If I hit enter and hit enter again, here is the array in ascending order. Well, I didn't put a line break in there, and I should have. But notice they are in ascending order. So let's fix that. I don't actually need this read line, so I can get rid of it. And I need a \n at the end of this. All right, let's see if I fix that. All right, so there's my 25 numbers in their original order. And there they are. So here are the numbers in ascending order. All right, and then it looks like I'm saying display them in their original order again. I don't know why, but that's okay. I'm not worried about that one way or the other. But if you notice, 3 is the smallest, and 92, if we look through here, is the largest. So that's working. Let's fix this problem because that looks pretty nasty right now. So let's see. All right. So after we do this, and after we display it, I'm going to move that read line down to there. All right, so let's look at it now. So here are your numbers in original order. Here are your numbers in ascending order. Okay, so that's working. I am going to put another read line in here just because it looks a little nicer. And let's put an extra \n in there. So file, save all. Let's run this. We get our original 25 numbers. Once I hit enter, there they are in ascending order. Okay, so that's working. Okay, now what do we want to do next? Well, we want the numbers in descending order. There's different ways of doing this. To me, one of the easiest ways of doing it is to come in here, static, void, sort, array, descending. And the first thing I'm going to do is I'm going to call the array.sort of numbers. It already should be in ascending order, but now I'm going to be sure that it is. All right. Then I'm going to call an array.reverse on numbers. So that's going to take what I just sorted. All right. And we'll put the read line in there. That's fine. And it should reverse the order. All right. So I'm going to call this, but I'm just going to change my message. Whoops. I'm going to change my message. So it says, here is the array in descending order. Let's see if that works. So there they are in ascending order. There they are in descending order. I'm sorry. There they are in the original order, then ascending order. Then there they are in descending order. Now we can have repeats. We didn't say that we didn't want any numbers to repeat. So if you noticed, we've got 2 zeros. We've got 2 98s. That's totally fine. All right. So far, we've come in here and we've initialized, we've sorted ascending, we've sorted descending. Well, again, different ways of doing this, just so you know, there's different ways. All right. But one way of doing this, I'm going to write that routine right now, static void. And I'm going to call array.sort again on numbers. All right. Why? Because the first one is the smallest value. I want to say that again. The first one is the smallest value. All right. I don't want to display the entire array now. No. I don't want to display the entire array. All right. What I want to do is just display the first element. So I'm going to put in here right. In fact, I'll make it a right line. No, we'll make it a right. It doesn't matter. Right line, I'll say the smallest array element is, and that's going to be numbers 0. Because we just sorted it. That should be the smallest. Let's put another read line in here afterwards. So there's our 25 in their original order. There's ascending. There's descending. You can already tell 1 should be the smallest number, and when we get there, 98 would be the biggest. So the smallest array element is, wow, it didn't show. So something's goofed up. That's probably on me. So let's look. Smallest array element is numbers 0. Didn't like that. I don't think I need a .toString on there. Oh, that should be a plus sign. There we go. All right. And if I want to put a toString, of course, I need the parens. Okay, let's try that again. So file, save all, original, ascending, descending. The smallest is 19, as you can see. All right. Then for the largest, I'm going to copy this. And we'll call this get largest. And I'll sort it, but after I sort it, I'll do a reverse on it. And now I can say the largest array element. And we can remove that. All right, so let's see if it's still working. And what I'm going to do is I'm only going to have one extra blank line in here. And we'll put one here. And we will put one here. All right, so let's see if it's still working. There's our 25 numbers in their original order. There they are in ascending order. There they are in descending order. So that should mean 4 is the smallest and 92 should be the largest if we did it right. The smallest is 4. The largest is 92. So all of that so far as I can tell, is working. So what's left? Well, we want to get the sum and then we want the average. All right, so get sum of array elements. That's real simple. All right, and I'll make a variable called sum. Int sum equals 0. And I'll put in this. Whoops. I'll grab that for loop just so I've got something in there. All right. Now, all I have to say is sum plus equal numbers LCV. It says add the current number to my sum. All right. Give me a read line. And says the sum of all array elements is, and that'll be sum. Not sum 0, just sum, dot toString. All right. Now, usually the sum should be somewhere around 1250. And what I mean by that is if I'm getting true random numbers, they should be pretty much, my list should be around an average of 50, and 50 times 25 is 1250. Now it's giving me an error here, so it doesn't like something. Oh, it says get sum of array elements. I must have called it something else. No, that isn't it. An object, oh, I didn't put static there, sorry. Remember, static basically replaces void when you are writing console apps. All right, so let's try that. All right, original, ascending, descending, smallest, largest, sum. All right, so it wasn't 1250, but it's pretty close. All right, then finally, all we've got left is the average. All right, and I'm going to just steal this here, hit enter a couple times, and I'm going to call this get average of array elements. Now, I could do it like this and get the sum all over again. I could do that. It really wouldn't hurt. All right, because then what I want to do after that, okay, if I do it like this, then I would want another variable here that would be a decimal that was called average, and I'll initialize it to 0M. And then when I'm done here, I can say average equal, and I have to cast, decimal sum divided by numbers dot length, or I could say divided by size. And I have to spell average correctly. And then I can say the average, or just put AVG, of all these is going to be average. And that'll work. It's not a problem. All right, it's totally fine to do that. Let's try just to be sure. Okay. All right. So this will be everything. There's our original numbers. There they are in ascending order. There they are in descending order. There's our smallest, our largest, our sum, and our average. Everything's working. In fact, if I hit enter again, it's going to give me 25 new numbers. So let's do this. Every time we run this, let's clear the screen so we can work with new numbers. So we've got that. The other thing that we could do in here is we could say, hey, you know what? We already have written this. All right. So there's two things that we can do. We could take sum that we created right here. We created sum, where are you? Right there. All right. And we're redoing it here. And that's not that it's bad, but I could come in here and do this. I could take sum up here and say static sum equals 0, like that. Of course, it does that garbage. All right. And I have to say what kind of variable it is. Of course, it's an int. The advantage of doing that is now I don't need to do any of this in here. I need my decimal average, and now I can just come in and say average equals sum divided by this. All right, this should still work just fine. All right, original, ascending, descending, smallest, largest, sum, average. Okay, it looks like it's working just fine. Now, when I hit enter, I'm going to get 25 new numbers. All right. Now, the only thing is, right now, the way this program runs is it calls these in that order every time. If I can be sure that that's what's going to happen, then I'm going to be sure I've got a sum before I call the average. If I wasn't sure, or if I wanted to give the user a way around this, all right, I'd have to write it in a different way. And that's what we're going to end up doing tomorrow, just so you know. So I'm going to save this. I'm not going to put it out there yet, because tomorrow we're going to rewrite this as a GUI. And I'm done in 2 minutes, but just to show you what it'll look like. All right. Oh, where did I put it? I think that's here. And it's going to allow me to introduce one thing that we're going to be getting into in the next chapter. So here is this is called a list box. This is a listing of all 25 of our numbers. All right. So we can still sort it in ascending order, sort it in descending order. If I go back to ascending, it should say the smallest is 1, and it does. It should say here that the largest is 88, and it does. It still does the sum, still does the average. It also does the range, and the range is the biggest number minus the smallest number, which is 88 minus 1. So the range is 87. It does the median, which says grab the one right in the middle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13. So it should give us 60, and it does. And it should allow us to search. And we're going to search for this in 2 different ways. This is actually going out and searching using a different programming language. So I'm going to show you how to do that. So notice if I come in here and I say, is 60 in there? It says the number 60 is in the array, but if I run it again and try for 61, it says the number 61 is not in the array. All right, then we'll use the search for C#, just so you can see the difference between them. And again, 60, it is in the array. 61 is not in the array. All right, and we'll have the ability to clear. When we clear, we create a brand new list. So notice every time I'm clearing, it's creating a brand new list and our old exit, which it doesn't look like I programmed, but that's okay. All right, so that's what we will do tomorrow. I'll save this along with the other one that I'm going to create, all right, for you tomorrow. So this was array console. So for tomorrow, I will create array GUI. In fact, I don't even know what I called the one I did, but they'll both be out there tomorrow. Okay. If you haven't done so, please try to read through chapter 8. If you do read through it and you have questions, feel free to email me and I'll be glad to try to answer them for you if I can. All right, it's 11:24. You didn't get one last break. That would already put us at about 11:40 or so. So let's just call it a period. We'll end right now. I will see you tomorrow morning at 8:05. Have a good rest of the day. Thank you.